Hello, everyone, and good evening to a new episode of Wissenschaft fürs Wohnzimmer, or Science in the Living Room. Today we have Marylou, a colleague from AVI, here with us, who will talk a little bit about how we can make predictions or how we can look into the future in terms of extreme events and what techniques we can use for that with models. My name is Stefan Juricke. I'm also a scientist from the Alfred-Wegener-Institute and from the Constructor University in Bremen. I'm working also on modeling, on ocean modeling actually, so I'm pretty close to what Marylou is doing. And I'm looking forward to her talk. Before we start, if you have questions, as always, put them in the chat. We will forward them to Marylou. If you have comments after the talk, just put them into the comment section below. And like us, or if you really like us, then just take a follow us in our channel, and we're looking forward to you in the future. And then I hand over to Francesca.
Hi everyone. My name is Francesca. We are all AVI people today. So I'm also from AVI. I'm a PhD in the physical oceanography group. So I'm more on the observational side, and I'm interested in sea level variability. And in particular, I use satellite data to study sea level variability in the Arctic region. And I'm really looking forward to hear the storylines that Marylou will tell us today. Valentin?
And I am Valentin Ludwig, also working at AVI, actually in the same section as Marylou, so we are colleagues. I work on sea ice drift predictions as a postdoc. And I'm looking forward to Marylou's talk. Marylou, I would say the floor is yours.
Thank you. And yeah, thank you very much for having me tonight. So thanks again for the introduction. My name is Marylou Athanase, and as you've all said, I am also at the Alfred-Wegener-Institut. I'm a postdoc for a few years now, and my main research topic is extreme events, and is in particular, how can we attribute and project extreme events using simulations? So I guess I can now start sharing the screen. And there we go. Okay, you should see it now, and you should see it moving. Okay, great. You do see it moving. Awesome. So as it was introduced, my goal of today is to tell you about something we call storylines. So what are storylines? Really, the point is that storylines allow us to tell the story of certain extreme events or extreme weather events in a changing climate. And of course, this work was not done, entirely by me, far from that. So I really want to give a big shout out to my colleagues from the Alfred-Wegener-Institut that are listed below here. So yeah, many thanks to them. Okay, so why do we care about weather extremes and extreme events at all? So you probably still have a bit of an idea what extreme weather events are. You must have seen that in the media quite a few times, especially in the last few years. And here is a bit of a collection of different pictures of what extreme events can look like and how they can manifest themselves. So of course, here you have a photo of droughts on the top right. You also have flooding events here in the Rhine Valley. So you can see with really devastating impacts on the habitations there. And at the bottom, you can also see different types of extreme with mega fires during really hot extremes. And onto the opposite side, you also have a cold spell, so really the cold extreme. And you can recognize our beloved Deutsche Bahn trains being really heavily frosted during this cold event. So the point is that you've seen extreme events, you know what you probably know, you can kind of grasp what that means. And you also have the knowledge that these events impact us heavily, not only us as societies, but also the ecosystem that live around us. So we care for that reason. We care about what happens to extreme weather events. But when I say weather and when I say changing climate, maybe it's not so clear to you what that means. What is weather and what is climate? What's the difference between the two? And that's actually really important for this presentation here. So I'm going to take a little step back with this illustration here. And this is kind of an example, some sort of thought experiment to explain what is weather and what is climate. So here you can picture this little machine that is in blue here, and you have a bunch of little red marbles on top. And these little marbles, they can just fall down through this machine, and they're going to encounter different obstacles. And every time a marble falls down, they can go either to the right or to the left of that obstacle with equal chance. And if you let go all of these marbles, you're going to see that at the bottom of your little machine, you're going to get a distribution that looks roughly like this normal distribution. So with more in the middle, with what would kind of constitute the mean, and less on the sides. And in this case, in this example, these little red marbles, that's what I would say is the weather. That's a singular event, one thing at a specific place, at a specific time, in a specific season. That's one realization, that's the weather. And it can be either on the far side, in the middle, or to the left side. And now you see that, like I said, these weather events make a distribution, and the collection of these weather events is making what we call the climate. So for a specific place, a specific time of the year, you're going to have this climate distribution. And this could correspond to different parameters. So at the bottom, you could say that this distribution is how warm or how cold we are for the specific place of the year at the specific place of the world at the specific time of the year, or how dry or wet, how much precipitation. So that's the climate. That's this distribution. And now when we talk about weather extremes, well, it kind of feels logical to say now that weather extremes are what is really at the tail, on each side, at the tail of the distribution. So extreme events are those little weather marbles that are very far from the mean. So they are extreme, but they're also kind of unlikely. So we see that we have one chance out of, I don't know how many marbles they are, but quite a few, one chance out of many to have these extreme events. So, okay, that's the difference between weather and climate. And this is what extreme events mean from a physical point of view, from a statistical point of view. Fine, but now what happens when we have a global climate change? So I take again this distribution here for any given parameter. Again, it could be temperature, it could be how much precipitation we have. And this represents really, again, this climate distribution. And this is in a world without climate change. And I leave for reference what was considered in this world without climate change an extreme event. So these dashed lines marking what would be extreme low or extreme high. So when we have climate change, what can happen is that we shift the mean. So you can easily imagine that if we have globally higher temperatures, of course, it means that on average, so this mean, this zero value further to the right, you're shifting your entire distribution, which means that the number of weather events, of these weather marbles that fall within the range of what was considered extreme is increasing. So that's why, potentially, because you are shifting the mean, you may have more extreme events. What can also happen is that not only you're shifting the mean, but you're also potentially increasing the range of possibles. So the weather is becoming potentially more and more variable, which means you have a larger range. Your distribution, your climate range here, your climate distribution is expanding, which means that's also a reason why you may have more extreme events, and not necessarily only on the high side, but also on the low side. And they can be actually also further complicated changes. So there can be very, very strange things happening with a lot of different processes involved. So when we see this, when we think extreme events in the future, really the questions that come up usually to our mind is, first, can we attribute these events to climate change? So by that, I mean, can we say it is the anthropogenic emissions that led to the occurrence of this event? So that's the question of attribution. And the second question is, can we project how these extreme events are going to evolve in a future climate, in a future warmer world? And that's the question of projection. So, okay, how is that done? How do we attribute and project extreme events? So the method that is traditionally used, actually mostly the one that is used, and essentially the one that is used in the IPCC reports, so this International Panel on Climate Change, is what is called the statistical approach for attribution and projection. So to do that, what you need is a large number of observations from the past so that you can make strong conclusions, or a very large number of simulations for the past, present, or future, if you want to. And with that, you are going to make up, these climate distributions again. And you can kind of say, if based on this climate distribution in the past, present, or future, if a certain type of extreme events is more or less likely, if we see more in the future distribution than in the past, and if they are more or less intense. So to give you a bit of a feeling of what we already know, this is a little example, a little excerpt from the IPCC report, the sixth IPCC report. And here you have a view, a schematized view of changes in likelihood and intensity for different types of extremes. You have hot extremes, heavy rainfall, and droughts. And these are for different parts of the world. So you can really kind of make up the contours of America to the left side, Eurasia, Africa, and Australia to the bottom right. And what you can see here is that, well, the red, green, and yellow colors, what they tell you is that for all these types of extreme events, there's really a tendency globally to have more and more frequent of these extreme events. And in particular for Europe, if you look at this thick black line here, this is Western and Central Europe. This is basically where we are right now in Germany. This is definitely the case. Actually, this is especially the case in Europe that we have more of these frequent events. So that's another reason why we really need to care about extreme events. Not only they have high impact, but they're going to become more and more present in our daily life. Okay, so that's good. That's what we know, and that's very useful. But of course, although these are absolutely necessary, this kind of approach, this statistical approach, also has a few shortcomings, and this is why I'm presenting this right now, right? And the shortcoming I want to talk about is, first, like I said, we need a lot of simulations to do this. We need really, really large simulations, and we actually need multiple different models to be able to have very strong conclusions. And having this actually takes a lot of resources and means we need a lot of time to perform these simulations, to gather the data, to do the statistical analysis. That's one thing. And the second thing is that because these are statistical, it's just, statistics, probability, you're grouping events per type. It means you cannot make specific conclusions. You're saying those types of events, so let's say hot extremes looking a bit like that in that part of the world, are going to change in this way. But you cannot say that event that we have lived is going to change in that way for that reason. So can we be a bit more specific? Can we pinpoint, really do attribution and projection for one part of the world, one time, one season, and one specific event? And this is where storylines come from. And with storylines, we're taking a little bit of a shortcut. So with storylines, the point is that we are going to look at the observed weather, but we are going to simulate that observed weather in different climates. So if I take back my little example from earlier, what this means is that we're going to follow one of these weather marbles through the climate machine, except we are going to shift the climate machine altogether. So we're going to follow that weather marble in a climate machine in a past, colder, pre-industrial world, but also in a future, warmer world. And this is what storylines are. So, of course, we have to be a bit careful because we are fixing the study. This simulation is really just fixing on one event, which means you cannot really have conclusions on whether or not this event is more likely, because what we are doing is that we are working under the assumption that that event is happening either in the past climate or in the future climate. So we just assume it would happen. That's what we do in the model work. But what storyline can do is, of course, answer the question of whether the event is going to be more or less intense and why. And we can also give results, in this case, for very specific events. And finally, of course, it's also really interesting because with these storyline simulations, you can be very, very fast and efficient in providing attribution and projection for these extreme weather events. So that's quite a few good points there. Okay, so how do we actually do storylines? So of course, you don't need to understand everything here, but I'm just going to go over the, let's say, the broad picture. So first, to do storyline simulations, what you need is climate simulations. It can be from a coupled climate model, so a model that represents both the atmosphere and the ocean. And here I put IPCC type because I just means climate simulations from a model typically that contributes to things like CMF6. So this the CMF6 being really the model component of the IPCC reports. So what do these climate simulations look like? So what you have is that you have a time series. So this is the simulation timeline, and you have 3 different chunks that I have indicated here with this on this arrow. So what are these different chunks? Well, here you have a photo here on this figure taken from a paper from colleagues here at AVI. You can see the global mean temperature through time in this climate simulation. The first trick is the pre-industrial, so meaning a world without climate change before the industrial revolution. So with really the very low emissions that were the case before 1850. So that's the pre-industrial, a world without climate change, let's say. And then you have the historical period here in black. And here, what is happening, you see that the temperatures start rising. And this corresponds to the time where we are really imposing the changes as we have actually observed them, as emissions, anthropogenic emissions were rising. And after that, you have what we call the future scenario chunk. And this corresponds to the projected emissions. So there's really different flavors of how things will potentially evolve. There's different possibilities. There are some scenarios that are quite optimistic. So that suppose that we're really strongly going to decrease our emissions and have a dampening of the global temperatures at some point. And there's some pretty pessimistic ones that suppose that it's going to be just business as usual, and we're going to continue emit a lot and have a very strong temperature increase. And the yellow here, the yellow future scenario, is considered at the moment as a realistically pessimistic scenario, let's say. And this is what we're choosing most of the times. And on this scenario, you see that a +2 degree world would be reached by the 2050s. And we would also reach a +4 degree world before the end of the century. So that's for the climate simulations that we use. And now what else do we need? So we also need to do something important, and that is constraining the observed weather and really constraining the observed winds. So actually, what does that mean? What you need to know is that normally the traditional atmosphere models, that is really the atmosphere part of this climate simulation I was just talking about, well, the atmosphere in these models has random weather, which means it does not reproduce the observations. It reproduces the correct climate, but not the correct weather, which by now you should know are 2 different things. So if I schematize that, if you take a certain day, you have a weather pattern that is observed, that are the gray lines here with the L for low pressure and H for high pressure. And in the model, in red, you have a different weather pattern, slightly shifted, not at the same place. And if you follow this through times, a few days later in the timeline, the observation pattern in gray still is going to move a certain way, and the model weather pattern is not going to follow it, of course, because the weather is random. But now, what do we do? So we're going to do something that we call nudging, meaning we are imposing the winds. So with nudging, what is happening is that at every time step, once we start the nudging, we are pushing the modeled winds towards the observed winds, because we know what the observed winds look like. So we know, what they should be looking like in the model. And what happens when you start doing this nudging, you start really reproducing extremely closely the observed state, as is schematized here. So this is what we need. And how do we combine these two things into making storyline simulations and start actually telling the tales of these extreme events? Well, so what we do is that we take again this climate simulation, and we are going to branch off from this simulation. So basically in 3 points, it could be sometime before or after, in the middle of the pre-industrial climate, or in the present day. So here we consider that the present is 2017, or at the end of the century, we can stop the simulation and say, okay, we're going to do something else from now on. So we start from this thermodynamical state. By that, I mean the correct temperature, the correct, moisture of the soil, and so on. We start from these states in the pre-industrial, the present, and the future in the simulation. And we start doing nudging. We start imposing these winds. And these winds are what we call the dynamics. And from that point, we will continue the simulation again. But then we will have the correct observed winds for a given period. So in our case, we chose the winds of the present day. And this is how we get storylines. So basically, storylines are just the weather of a certain period, in this case, 2017 to 2020. But if it occurred in a different climate. So in the present, we still have, the correct weather for the present in the present day climate. So we just reproduce reality. But then we can do this in the pre-industrial and in the +4 degree world. So we have, again, these hypothetical simulations that are storylines, that are what if the weather of 2017 to 2020 happened, but in a colder pre-industrial climate? Or what if it happened in an even warmer future climate? And this is what storylines are. All right, so we know how to make storylines. Now I'm going to tell you a little bit what we do with these storylines and what really they look like. And really, this is a really great example, again, from colleagues at AVI that I really thank warmly for this. So this is a simulation of the storylines that were made for the summer 2019 European heatwave. So in the center, you can see here let's say the present time. So in July 2019, you're going to see this as an animation. And the background color is the temperature close to the surface, and these little shades of white corresponds to the high level winds. And you see that on the left side, we have the same thing, but if these winds happened in a pre-industrial climate, or if these winds on the right side, if these winds happened in a +4 degree world. And of course, you see the same winds everywhere in all of those 3 figures here, and that's normal because we are imposing these winds. But what you should see is that this near surface temperature, the colors are not exactly the same. Although they evolve similarly, they are not the same. I'm going to stop here towards the end of July 2019, which was really at the peak of the heat wave at the time. And I personally was living in Paris at the time, and I remember that it was extremely warm. It really, when I exited the office, it really felt like I was just opened an oven door or something. So it was really, really difficult to bear. And you can see that, if you look at France, you can see that in the present day, in 2019, there was temperatures well above 30 degrees, probably quite close to 40 actually. And what is really striking and kind of frightening, if you're French or Spanish, you see that all of Spain and France in the future is easily going to go above 40 and very, very close to 44 or 45 degrees Celsius, actually. And if you're not French or Spanish, but you're German, you can also look at Germany, and you can see, of course, that although Germany in a pre-industrial climate would not be above 30 degrees in the future, it would really be well above 35 degrees Celsius. Okay, but so really what is interesting with the storyline here is to say, actually, a +4 degree world does not mean that we just add 4 degrees everywhere to every event, to every weather. It's not like that. In this case, actually, what we see with the storylines, because we account for all the interactions between the land, between the atmosphere and the ocean, because we have this, we can say that for this extreme European heat wave, the warming, if we had something similar in the future, if we had the same winds in the future or something close to it, the warming would not be +4, it would be +10 degrees. So that is really the kind of information that is truly important to know. So, okay, so that was really one example for an atmospheric heat wave. But there is really a whole range of different extremes we can apply storylines to. And I'm going to go over this a little bit quickly and just give you a brief feeling of what can be studied and what can be concluded using storylines. So first, you can remain in the realm of hot extremes, but towards the ocean, because I have a background in oceanography. Of course, I'm interested in the ocean. And this is something I've been looking at. So you can apply this, again, these storylines to an extreme ocean heat wave that happened in 2019 off the coast of North America. And actually, the interesting thing is, again, you can not only attribute this marine heat wave to climate change, so that the intensity would have been way less without climate change, but you can also, with storylines, again, accounting for all these different atmosphere-ocean interactions, you can actually also conclude that there's going to be a warming 50% larger for marine heat waves in the future. Okay, droughts. Storylines were also applied to droughts. So still in South America, there was an example for a drought that happened in 2011 and 12 by some colleague of us. And actually, storylines here again, because they have all this interplay between the atmosphere, land, ocean, etc., they really show that there can be competing effects, actually some counterintuitive things happening. So in their case, there were warmer temperatures, so more evaporation, but also more tendency to a wetter soil, so with more precipitation and a soil that is wetter. So that kind of, more evaporation, wetter soil is kind of fighting each other when it comes to droughts. And that's really the interesting thing so storylines can bring. And finally, the last example is extreme rainfall. So you can also apply this to cases of intense precipitation. And if you were in Germany, France, or Belgium in 2021 in the summer, I mean, you must remember that in July 2021, there was really super intense floods in the Rhine Valley. And using storylines, once again, some colleagues have been seeing that these floods were about 10% more intense than there would have been if there was no climate change. All right. So really, the fact that the storylines can capture all this interplay leads to really quite some detailed insights, not only on the impacts of these extreme events in the future, but also on the processes that lead to their evolution. So from a scientific point of view, this is really important. And the last really thing I'm going to talk about now is just this other strong point of storylines. So here you see that there's this, you recognize this, you're probably familiar with this view. This is a weather chart. And this is a weather chart from July 2019. And these are actually the temperatures that were in Germany at the time. And we see this all the time, on television or whatnot. And we know this kind of view. So you can easily also, again, imagine that with storylines, we can do the same kind of weather charts, but for different climates. And that really is truly helpful when it comes to making the effects of climate change tangible. Because when you look at this map and you know where you were in that country, you can really pinpoint, well, you can actually look potentially at the pre-industrial weather map that corresponds to that specific event you're interested in and say, okay, this is what is going to be, what it is going to be like in the +4 degree world for that specific town. And you could, you could imagine that if tomorrow there was a heat wave warming on television or on the weather forecast, and they show this kind of map for tomorrow, if you had storylines for this would really be interesting in terms of informing people when it comes to adaptation measures or even just individuals that want to understand what climate change means for them. Okay, so I'll wrap up. Just briefly summarizing the key messages here. So why do we care about extreme events? We care because they impact us and because they have a tendency to become more and more frequent, especially for us in Europe. And this is where storyline can help because they really provide a very rapid and efficient attribution and projection of these extremes. Of course, we have to be careful. So we cannot apply storylines to absolutely every single event, because if you have weather events that become incredibly unlikely in the future, well, these what if simulations become a little bit less relevant. But for all other extreme events that remain quite plausible in the future, this is absolutely relevant. And finally, and I think that's really the most important thing here, storylines really can truly help when it comes to making the effects of climate change more tangible for everyone. And they really can answer the question that you can ask yourself: how would this event that I experienced personally, that I maybe suffered from even, how would this event look like in the past or in the future? Okay, so that's all for me. Thanks for having me. And if you have questions here, I would be really happy to answer them.
Thank you very much, Marylou. Can you unshare so that I can just, before we go into the questions, I mean,
Sure.
Between us, we already have quite a few. We also give the audience some more time to ask questions in the chat. Before we go there, I just want to briefly talk about what's going to happen in 2 weeks. In 2 weeks, we will have a talk by Fieke, also from the Alfred-Wegener-Institut, talking about, this will be in German again, actually, so Wissenschaftler arbeiten an der AVI per Forschungsbasis. So this is a 20-year, as far as I know, the 20-year anniversary of this station, of this scientific station. And we will have a look at what kind of science do they do there, what have they done, what will they be doing, what are they looking at, how has it evolved, how has it developed, how does it look like there. We already had a few talks about stations like AVIPEF, but this will be sort of a summary over the last 20 years of this specific station. So we're looking forward to that in 2 weeks. And with that, I think I pass over to Francesca to ask the first question.
Yeah, so really interesting and clear. And actually in the chat, the first question is from myself. So I'll go ahead with that. I think maybe this concept of the nudging is quite complex. So I wanted to ask again if I understand that, because I think I understood it today for the first time. So is nudging actually needed in the storylines so that you can reproduce the same dynamics in different scenarios?
Absolutely. So that is really what makes storylines, is because you need to reproduce the evolution of the dynamics. So you need to reproduce the evolution of the winds so that you can drive the same or similar weather at least. And really this notion of evolution is really crucial there. Really the fact that you have the same increase in the same places at the same time, that is really, if we didn't have this, we couldn't make storylines. And we do this by nudging the winds.
Yeah, because originally I thought, can't you just let the weather go and look at what happens? But of course, then you couldn't reproduce this in another climate scenario, right?
Yeah, so actually, if you don't have the nudging component, you go back to what is done in the traditional statistical approach. What they do there is that they group events by similarity. So they're going to take a bunch of heat waves that happen in the model world for different reasons. Usually they try to group them by similar reasons, having similar configurations in the winds. And they group them, so that's how they make statistics. If most of them evolve in a certain way, you can derive statistics. But to actually derive robust statistics, you have to have a lot of these hypothetical configurations, and that's what makes it difficult. And that's where storylines can nicely complement.
Yeah. Okay. Yeah. Next question, I guess, for Valentin.
Yes, and I think I'm not asking my own question, but Stefan's question, which I find also very interesting. Marylou, for the attribution of the intensity of these events, is it true that you need both the information how frequent this is in a statistical sense, as well as the storylines? Can one put it like that?
So I'm not fully sure I understand the question, but absolutely, I would still say you need both. You completely need both, because you cannot, you cannot do without the traditional approach, because you need to keep this idea of likelihood. You need to know whether or not there's going to be an increase in likelihood, and that you cannot do with storylines. But where storylines complement is not only because they provide information about the intensity change, but also because if you group different events that look the same, you might actually still not have events that are exactly the same, which means that the processes that are responsible for their evolution may not be the same at all. And the fact that we really isolate specific events with storylines, that's what makes it possible to really say, okay, that heat wave becomes more intense, becomes really worse for everyone for that specific reason. And that is really, really helpful, because, well, we need to understand things better if we want to project things better also and adapt to them. So, yeah.
Okay, cool. Stefan, did that answer your question?
Yes, it did. Thanks also, Marylou, a lot for this very nice talk, also for clarifying again what the difference between weather and climate is, and for this nice analogy with the marbles. I thought that was quite explained it really well, and also the nice pictures, of course, even though I know that you got them from colleagues, but still these videos are very nice to illustrate how things could look like in a future world. I really like that. It's actually maybe something that actually is, as you mentioned, maybe we could have that for the weather forecast if we know. And there actually my question comes in. So how quick can you do these attributions? Say, for example, that we know that in the summer, I don't know, on a Monday, you know that on Wednesday it's going to be extremely hot, and it's going to be likely that there might be a new temperature extreme or just a normal heat wave. Is that envisaged that you will be able to produce something like this on a actually 3-day ahead basis, and that you can actually provide this to the public? Because I know these other attribution studies, the statistical ones that you mentioned, they usually come out a few days or maybe a few weeks after the event happened, and then they try to say how likely was it in a past climate that something like this happened or something like this did not happen. Could you do this very quickly then?
Yeah, so I guess the short answer is yes, but I will obviously add a bit more to it. So hypothetically, so in practice, to make storylines, like I said, you need first these climate simulations, and then you need to branch off from them, and then you need to make storylines. So of course, preparing let's say the paving the way for the storylines to be made takes a bit of time. But once you have the start, if it's just about extending the simulation for a few days, if I know there's going to be an extreme event tomorrow, if I get the data tomorrow for tomorrow's weather, the answer can be, again, theoretically, it can be done within 1 day, I would say, for 24 to 48 hours. Of course, then you need to be a bit, you need the workforce to do the analysis. You need people to look at the data, but the simulation itself and preliminary results can be extremely quick.
So will you then approach, I don't know, the öffentlich-rechtlichen to like the television channels to actually produce these plots? Is that a plan?
So I guess on my side, that's a wish. And I don't know how much I can say really, because I mean, there has been some discussion, not from television side, I guess, but there is definitely interest from the media side to have a collaboration, either for specific cases of events that really made the news, but also potentially to do things very quickly. But it's in the making, so stay tuned, I would say.
Thanks a lot.
Nice. I do have another question, and actually before that I have a comment in this, let's call it nice animation, even though it's also terrifying with this 40 degrees weather. I was just looking at my own, the region where I come from is just this northern Italy, this very hot triangle, so it's quite scary. So my question to you was whether as an oceanographer, is there one storyline that you would be interested in looking more into, like one process, how that would that evolve with the future climate, or have you looked already into something?
Yeah, so among the things I introduced, of course, I'm working on marine heat waves at the moment, and I find this absolutely crucial, of course. So I've been working on marine heat waves in the North Pacific, like I said, but something that is maybe a wish or wishful thinking. I personally would really like to look at something closer to home. And in particular, what happened in the Mediterranean Sea in the last few years. So we know we've had some really extreme years in terms of how warm the Mediterranean Sea was, and especially last summer was really absolutely dramatic. And we also, we know that there's probably a lot of impacts for all the ecosystems there, but also because there's so much activity, economical activities from our societies on the Mediterranean Sea there, that really, the fact that this is so high impact potentially really makes me interested in doing storylines for the Mediterranean Sea. Yeah.
Yeah, interesting, definitely. Oh, I guess, is there another question from Valentin, right?
I do actually have a more or less even follow-up question. I was wondering, we're talking a lot about like risk assessment and adaptation strategies and so on. And it sounded to me as if the storyline simulations could be a valuable tool for this, like to identify regions of high risk, be prepared better for future extreme events.
Yeah, so actually, I guess I can do a bit of advertisement. So this is actually to some extent, the topic of a project across different Helmholtz Research Institute in Germany. It's called Scenic, and obviously I'm part of that together with more colleagues from AVI. But yeah, of course, so the point there of this project is to collaborate with people who do impact modeling to see how far we can get, so we can provide to them the physical side of things. So how, the climate response is going to be of these extreme events. We can give them that. And then in turn, the hope is that they could take this physical information and turn this into risk assessments and yeah, projection of impacts. Yeah. Yeah, so absolutely. The end goal is to obviously help these discussions around adaptation and risk.
That sounds pretty cool. Stefan, I think you had one last question.
Yes, exactly. So my question would be, is there sort of a plan what things to look at next? And you talked about the Mediterranean, that this is something that you would like to look at, but is there a specific strategy that you will look at more into droughts, or more into extreme rainfall, or more into the ocean heat waves, or something like that? Or is it that you really go event by event that just comes across, and you think that might be also like scientifically interesting from, as you said, you're not just using this to shock people into being scared of the climate change, but it's also to better understand how the physics work, right? How these events are built up and how they are intensified locally and so on.
Yeah, so that's actually a very good question. So this is so of course I mean, there's two things. Storylines is just a really nice tool, and I think more people should use it, and that's why we're communicating about it, because I think it can help a lot of things. But then, of course, doing case studies only is not going to be sufficient. So, of course, there is discussion around doing something more on a bigger scale, doing multiple storylines for different types of event, maybe focusing on Europe again as part of this project we're doing across institutes in Germany. So yeah, this is kind of all very new. So there's a lot of discussions going on, and I'm sure, future will tell. So that's really one thing that I don't have a clear answer for. But yeah, for sure, the aspect of getting these storylines done closer and closer to the real time, to how we experience these extreme events as we experience them, being able to do storylines almost directly after we experience them. Yeah, that would be absolutely critical, not just for the purpose of science, but also for communicating the science to people.
Maybe before we close, that brings me to a last follow-up question before we say thank you to you. That the last sentence, basically, you said, you gave a 30 minutes talk now, and this is a very complicated method. I mean, it's not, maybe not so complicated for you, but for a lay person, it sounds like something that is not something that you do in everyday life. But we see this in the media a lot, that they do these attribution things very quickly after these events and so on, and try to communicate this is what would have happened in the world with some 4-degree temperature change or something like that. How do you see this? How can you best actually communicate something like this? Do we need to be more specific in the way we tell these stories to the public, or is it something that hopefully at some point will be in everyone's head what it means? Because attribution is a tricky word in a sense, right?
Yeah, it's not an easy question, actually. So I would tend to say, so there's two things usually in these attribution studies. There's the likelihood, which is really the dynamical side of things. Can this even happen? And there's the thermodynamical side of things. So is this event as intense because of the change in the thermodynamics, because we have a warmer climate? And I guess there is part of a bit of a complexity aspect to these studies, because you mix the two. You mix dynamics and you mix thermodynamics. And the good thing with storylines is that at least you remove one of these things. And I think it's may make things easier to communicate with storylines than with the traditional approach. Not saying we don't need it, just saying we also need storylines. Yeah, and then I guess for really to finish answering your question, how we can best communicate this, I guess this idea of having these weather charts made up with storylines might help, because it's not just hypothetical. It's not just, oh, on average, it's going to be a bit warmer in your area than normally. It's really the weather you're going to experiment tomorrow. We can tell you how it's going to be if the climate gets warmer. And if it was actually, in an ideal world or in a future world, if it was always provided every time we give a weather forecast, I guess, you could not tiptoe around the matter anymore. You'd have to see it. So maybe, but yeah, we're not there yet.
Thank you very, very much, Marylou, for this very nice presentation, all the nice pictures, and well, even though, as Francesca said, they're quite shocking, but they're still pretty. And
pretty but dangerous.
Pretty dangerous, but dangerous, yeah, and informative, I guess. Thanks again very much for this. And to the audience, if you like this, please give us a like. Follow us on YouTube, and we will see most of you in 2 weeks' time when we have our next presentation. And with that, I say goodbye to everyone and have a good night and farewell.